Okay, we want to find the coordinate of R, where R is the intersection between the blue line and this light brown line, where the blue line is the normal to the curve at P, and this line here is the normal to the parabola at the point Q. We've got the parametrics equation for P and also Q. So we are trying to find what R is. Yeah, that's what's the X coordinate of R and what's the Y coordinate of R. We start by saying that the normal equation the normal equation at any point of the parabola has this form, where t is the parameter and they are there. So in the blue line, the parameter here is p. So I have in place of t, I've substituted with p. And the same thing goes for the coordinate q. The normal at the point q is y plus qr equals to 2aq plus aq cubed. If I want to find the intersection, basically what I need to do is I have to use simultaneous equation. And subtracting them by column, y take away y, px take away qx, 2ap take away 2aq, and ap cubed take away aq cubed. Now that gives us this. Notice that y's cancel off. That take away that's finished. I've got p minus q here with the x outside. P minus q with the 2a factorized. Likewise, a factorized here, and that's p cubed minus q cubed. I now want to try to simplify this value of x. I can expand, well, actually factorize p cubed minus q cubed. That is the same as p minus q multiplied by this whole thing here. So I end up with p minus q, which can be cancelled off there, and there. Simplifying calculation, I get the coordinate value for x. So with that, I can find the value of y. Pick any of those equations, either the blue or the brown, doesn't really matter. Both should give you the same answer. Substituting the value of x. So x there, it now goes in there. And again, you simplify, you get y equals to ap times pq plus q squared. So what happens is that I've got 2ap here, and you see 2ap, that one can cancel off. ap cubed, that's ap squared and p there, so that's ap cubed. So that cancels off as well. So I'm going to end up with just that one, and you see it is there. And if I factorize it further, I get negative apq p plus q. That's the coordinate for y. So I've got the coordinate of x and the coordinate of y. Putting them together, that's the coordinate of the point R. And R is the intersection of the normal passing through P and the normal passing through Q.